Did you know that Cisco switches used to run an operating system called CatOS? Yes, seriously, CatOS. That was the operating system for switches such as this. This is a 5500 Cisco Catalyst switch. This switch was manufactured in 1998. What were you doing in 1998? This switch is a 5500, 5 slots. Top slot is the supervisor. This is running CatOS. Here we've got FDDI, old ring technology that used to use light. Here we've got an RSM, or route switch module. This is a router inserted into the switch. Logically, this acts like a router on a stick, but rather than having an external router and a separate switch, the router is inserted into the switch connected via the backplane. This router runs Cisco iOS. So we've got the supervisor, the brain, if you like, of the switch running CatOS. This is running iOS. This is what's called a hybrid switch because we're running both operating systems. Here we have an Ethernet module with 12 Ethernet ports, and here we have another one with 24 Ethernet ports. This brings back some memories for me. I've been doing this for so long that I remember configuring switches like this many years ago. I really want to thank David for sending me this 5500 series switch and a whole bunch of other devices. Without his help, I wouldn't be able to create as many videos as I am in my retro networking series. So big thanks to David for sending me this device, refurbishing Cisco devices and being part of the circular economy. Let me show you how to configure the switch in 2025, get it booted, get it configured, and then get it onto the internet. So the first thing I'm going to do is plug in this Cisco 9200CX switch, very modern Cisco switch. So I'll plug it into, say, this port. That will give the 5500 series switch access to the internet. This switch is connected to the internet via this red cable. What I'll also do is connect this laptop via Ethernet. So let's just choose a port on this module. So PC is connected to a port on module 5. The 9200CX switch is connected to this port on module 4. RSM, once again, is in module 3. FDDI here and supervisor over here. To configure the switch, we need a console port. So what I've got here is USB to DB9 male, DB9 female to DB25 male. So I'll be using this to configure the switch. So I'll plug this into the console port of the switch and plug this into the laptop up here. Now the router, or RSM, also has a console port. So what I'll do here is take a Cisco rollover cable. So I've got USB to male DB9, which I'll connect to female DB9 here. And on the other side, I'll take the RJ45 connector, and that allows me to connect to a DB25 port. DB25 here, I'll connect that to the RSM. You don't need that. I'll show you in a moment how you can jump from the supervisor to the RSM. And I'll connect that to the laptop as well. So I've got 2 USB connectors on the laptop. That gives me access to the supervisor on the switch as well as the RSM on the switch. In other words, switch, layer 2, and layer 3 functionality. In the old days like this provided layer 2 functionality, and the layer 3 functionality or routing functionality in the TCP IP model, or OSI model if you prefer, was done by the RSM. So the supervisor module is in charge of the switch, the CAM table or MAC address table if you prefer, and the router is in charge of layer 3, in other words, routing. I'll plug in the power cable, and now let's boot it up and show you what a switch looks like from the 1990s. But on my PC, before I do that, I'm going to go to Device Manager and look at COM ports. And you can see I've got COM3 and COM18. So I will connect to COM18 using PuTTY. Nothing is displayed at the moment. I'll open up another session, and the other port is COM3. So I'll connect to that as well. That'll give me my connection to the switch and the router. So moment of truth, it's going to be a bit noisy, but hopefully it doesn't destroy the audio. I'll turn the switch on. As you can see here, ROM Power Up Diagnostics, April 26, 1999, a long time ago. Checksums are done. Everything is passed. Switch is now booting up. Okay, as you can see now, module 1 is online. Module 4 is online. Here's my console. You can see the date here, 2025, January the 20th. Module 5 is online. So I'll type enable, press enter. Notice the command show run doesn't work because this is CatOS. This is not iOS. Show version works. You can see that this is running WSC5000 software, compiled June 4, 2004. So you can see various modules in slot 1, slot 2, slot 4 other modules are coming online. So before I continue, let's actually do this. Show module. And as you can see there, we've got module 1, 2, 3, 4, and 5. We've got our supervisor module in slot 1. So here's our supervisor. I've connected to the console of the supervisor module. Slot 2 has FDDI, 2 ports over there. We have an RSM in slot 3. So once again, this device over here. We've got 12 Ethernet ports in slot 4, as well as 24 Ethernet ports in slot 5. These are 10100 Ethernet ports. These are not gigabit Ethernet ports like we have today. So very, very old. Now I have pre-configured the switch with some configuration. I will reset it so that you can see the full process. But if I type show config, notice it's different to show run. You can see information here, such as IP address or learned from a DHCP server. This interface, SC0, is the management interface of the switch. This is how you set a static route as an example. You can see some DNS information has been configured, some NTP information has been configured, and we can see the modules on the switch. What I'll do just for this example is show you that I can ping the default gateway and I can ping google.com as well as cisco.com through the switch. All I had to do was configure the switch to use DHCP, bring up the management interface, and point it to its default gateway, which is a router connected to the other side of the switch, and it can get access to the internet. I have a switch from the 1990s accessing the internet with some very basic config. I'll reset the switch in a moment so you can see that. But again, my PC is connected to the switch. So show port shows me, firstly, that this port 4/5, so slot 1, 2, 3, 4, this module in slot 4, port 5, is connected to this switch, and the interface is up. I can also see that this interface, slot 5, so 1, 2, 3, 4, 5, 17 is connected to the PC. So 2 ports are up at the moment on the switch. Show CDP neighbor shows me that I've got a device connected to port 4/5. So once again, this cable here is connected to this switch. C9200CX switch is my neighbor, and its port is gigabit 101. And hence I can ping google.com because traffic is going through this cable. If I unplug that internet cable as an example, you'll notice pings fail because connection is broken. If I plug that back in again, after a while, I'll get access to the internet. There it says name lookup failed. Spanning tree will have to converge here so that the switch can access the internet. And there you go. So Google is active, Cisco is alive. So on the PC, so this laptop connected to this port, can we get to cisco.com? And the answer is yes, we can. Notice they say celebrating 40 years of innovation. Cisco recently had its 40th birthday. And if I go to google.com and say, what's today's date? You can see Monday, the 20th of January, 2025. I can access the internet through this switch. 1990s switch connected to the internet in 2025. But let's reset the switch. So let's go through the whole process. Now, before I reset the switch, again, this switch is running CatOS, but the RSM is running iOS. So on the switch, I can type show version. Notice different output to what you would normally have with an iOS switch. If I try iOS commands such as show run, that doesn't work. But if I type session 3, and the reason for that is because module 3 has the RSM in it. Notice the console prompt changed from console enable to router. I have now jumped internally from the supervisor to the RSM module. So here, if I type enable, notice this is iOS. Show run works. We can see the version of iOS running on this RSM. Show version here. You can see it says Cisco Internet Operating System Software or Cisco iOS. This is not phone iOS. This is Cisco iOS. You can see information about the router. If I type exit, I am back on the supervisor module. So again, this is a hybrid switch. It's running CatOS as well as iOS. The layer 2 functionality is CatOS. The layer 3 functionality is iOS. The router is logically connected as a router on a stick internally within the switch. But before I continue, let's reset the switch and then I'll show you the full setup. So what I'll do now is clear the configuration of the switch. So config, and let's clear all the configuration of the switch. And I'm told this will clear all configuration in NVRAM. Am I happy to do this? Yes, I am. I'm basically resetting the switch to factory defaults now. And you can see the configuration has been cleared. And we're told we need to use the session command to clear ATM or router specific configurations. Now, to do that, I'll go to session 3 once again and type erase startup config, and I'll reload the router. So I've now been pushed back to the console of the switch. Notice show run doesn't work here because I'm in CatOS. So I'll type show config. And what we'll see here as an example is that it's already learned an IP address from a DHCP server, but no other configuration exists on the switch. So just to prove the point, I'll reset the switch just to reboot it and show what happens with a default or reset configuration or cleared configuration and the switch booting up. Okay, so there you go. Switch is booted. I'll type enable to go to enable mode. Show config shows us the non-default configuration. Notice the modules are still coming online, so the config command took a while to display. But there you go. We can see some configuration on the switch. Let's do that again. So show config. It's taking its time, but you can see PAGP port 4/5 is joined bridge port 4/5. So in other words, this port has come up. We can see the same with port 517. So that port has come up. I'll press spacebar and notice we can see the configuration. Okay, so let's try that again. Show config, third time, lucky. Hopefully there's our switch configuration. You can see almost no configuration on the switch. So again, IP address hasn't been configured or anything. Module 3 is now online. Module 3 is the router. So show module shows us what's in the switch. There are our modules. Status is showing okay for all of them. So that's a good sign. Show port shows us that we have a trunk port to the route switch module that's connected. That's internal in the switch. So connecting from the backplane to the RSM. We have port 4/5 up again, this port here, as well as 517, that port over there being up. Okay, I'll quit that. Show CDP neighbor. We can see our 9200 series switch through CDP, but let's try and ping google.com. Notice invalid host address. We haven't configured the switch with any information. So now we need to use set commands. So set, and what are we going to set? In this case, I want to set the SC0 interface to use DHCP, and I'm going to renew that. So notice it's sending a DHCP request. Show interface. Okay, you can see it took a while, but it got an IP address. So show interface, question mark, and I'll press enter there. You can see the switch got an IP address from a DHCP server. So DHCP server is on the other side of this Cisco 9200CX switch. Switch has got an IP address. So can we ping our local IP address, which is this address? Yes, we can. Can we ping the default gateway? Yes, we can. Can we ping google.com? At the moment, no. Let's set a DHCP, or rather DNS server information. So set IP DNS server 8.8.8.8. Okay, it says that's a backup service. So that means it's already got a DNS server configured, and there it is. That was received through DHCP. So let's say set IP DNS enable. So enable the DNS service. Can we ping cisco.com now? Yes, we can. So we had to enable DNS. Can we ping google.com? Yes, we can. So again, show config. The switch has learned this IP address from DHCP, so I didn't have to configure that. So DHCP server is 192.168.0.1. Default gateway is that. That was automatically received through dynamic host configuration protocol. So was the DNS server. I manually configured that one and enabled DNS. This was automatically learned, hence the time showing correctly on the switch. We can see the modules, very basic configuration. So let's look at spanning tree. So show spanning tree, and it's actually span tree here. We can see that for VLAN 1, spanning tree is enabled. Type is IEEE. Designated route is this. That is the same MAC address as the local switch. Same with the priority. Notice the cost to get to the route is 0. So this switch is the root switch. It's a very old switch. In spanning tree, the lowest priority or lowest MAC address wins. So this switch is the root switch. We can see spanning tree port information here, but let's actually telnet to the other Cisco switch just to make the point. So show CDP neighbor. And what I'll do here is use detail to see the IP address of the Cisco 9200 series switch. So that's its IP address. So I'll telnet to 192.168.0.201. I'll log in, show spanning tree. Now in this case, I'm working on this switch. So show spanning tree. You can see it's using rapid spanning tree. This is its cost to get to the root switch. So its root port is gigabit 101, which is the port to the 5500 series switch. It's also got this port, which takes us to the internet. So both those ports are forwarding. So again, on the 5500 series switch running CatOS, you can see that it's the root switch. So we have interoperability between a really old switch and a very modern switch using spanning tree. Spanning tree is there to stop loops in the topology. And to make the point, I'll plug in another Ethernet cable. So let's take this port on the supervisor and plug that into port 2 on the other switch. So show spanning tree. These two ports were previously not connected, but now port 1/1 has come up. So I'll type that again, show span tree. You can see it's busy listening at the moment. Now it's gone to the learning state. Again, that's the port on the supervisor. And now it's gone to the forwarding state. So let's see if anything changed on the 9200 series switch. So switch at the top here, show spanning tree. As you can see now, things have changed. Gigabit 101 has become an alternate port that's blocking. Gigabit 103 has now become the root port. So why did it do that? Let's have a look on the Catalyst switch. This is port 1/1 with a cost of 19, priority of 32. This port, however, has a greater port number, so 4/5 with a cost of 19, priority of 32. So this is seen as a better port to get to the root switch. So again, on the Cisco iOS switch, show spanning tree, it's determined that gigabit 103 is the better port to get to the root switch. Gigabit 101 is now blocking. Okay, so simple example with spanning tree. Now again, this computer can connect to the internet, show port. The port that it's using is 5/17. Show VLAN shows us that all ports on module 5 are in VLAN 1. So show VLAN 1, all ports on VLAN 1 here. I could create a VLAN, so let's say set VLAN 2, so make VLAN 2. But it tells me that I cannot add or modify VLANs on a VTP server without a domain name. So show VTP domain. I haven't got a VTP domain configured. So set VTP domain, let's just call it Cisco. So show VTP domain. You can see the domain name is now Cisco. So let's create a VLAN 2. VLAN 2 is now configured. So show VLAN shows us that we have VLAN 2, but no ports are currently configured in VLAN 2. So set VLAN 2, and the port that I want to configure is 5/ and let's scroll up here, 5/17. That's the port where the PC is connected. So I would say that to put it into VLAN 2. Before I do that, however, on the PC, let's set a continuous ping. So ping cisco.com. At the moment, this PC can ping cisco.com, but if I change the VLAN number to VLAN 2, notice the pings time out. I haven't set up inter-VLAN routing or anything to allow this PC to get to the internet. So at the moment, show VLAN shows me that 5/17 is configured in VLAN 2, but I haven't configured a router to allow VLAN 2 access to other VLANs. So let's configure that port back to VLAN 1, so 5/17, and hopefully after a while, pings should start succeeding. Okay, it took it a while, but there you go. PC can now ping cisco.com because I've moved it back to VLAN 1. Okay, but let's configure the router. So at the moment, show CDP neighbor on the switch shows us that I've got 2 connections to the 9200CX switch, but I don't see the router. So I'm going to type session 3, because again, the RSM is in slot 3. That takes me to the router now. Show run shows me that I have really no configuration on the router. So I'm going to say host, let's call this RSM, interface VLAN 1. IP address, and let's configure it with an IP address of 192.168.0.254, so something like that. No shut it, and let's configure VLAN 2, and let's keep the numbers consistent here to make it 2 now, and no shut that. So show IP interface brief. What I've configured is an IP address on VLAN 1 and an IP address on VLAN 2, but VLAN 2 is currently down. But hopefully on this router, I should be able to ping the default gateway, which I can. If I configure the DNS server, I should be able to ping the internet. So IP domain lookup, IP name server, and let's just make it Google for this example. Can the router ping google.com? Okay, it's not working. Let's try ping 192.168.0.1 again. Ping 8.8.8.8. So the DNS server, not working because what I forgot to do was set a default gateway or default route. So conft IP route, bunch of zeros, 192.168.0.1. Let's try again. So ping Google DNS, that works. Ping cisco.com, and that also works. And I'll save the config. So the router can now ping the internet. Show CDP neighbor on the router. Notice it sees a neighbor relationship to the 5500. I'll exit and go back to the switch. And notice on the switch now, show CDP neighbor, it sees the 9200 series switch. So the switch here, it sees the RSM. So the router as a neighbor, as well as the 9200 series switch. The RSM again is acting like a router on a stick. So logically, it's connected via cable internally. So session 3, back on the router now. Show IP interface brief again. Notice we've got a VLAN 0 interface. That's a logical interface to the switch. Now, before I troubleshoot why the VLAN is down, I'll set up a DHCP pool. So IP DHCP pool. Let's create a VLAN 2 pool network 192.168.2.0 with the subnet mask. Default route is 192.168.2.254. DNS would be Google, let's say. So when I move the PC into VLAN 2, this is the information we'll use. So show run again. There's the VLAN 2 DHCP information. I've got the SVIs or switched virtual interfaces here. Now I just need to figure out why the interfaces are down. Okay, so this VLAN interface is down. Let's see if we can fix that. So I'm going to jump back to the switch. So the supervisor module, show VLAN, shows us that no ports are in VLAN 2. Now this setup is clever enough that the switch or the supervisor module tells the RSM that there are no interfaces in VLAN 2, so the SVI or the layer 3 interface on the router goes down or stays down because no interfaces are in that VLAN. So what I'll do is set this port, which is the port that the PC is connected to once again, to VLAN 2. So the port is now in VLAN 2, so show VLAN shows us that. That interface is now in VLAN 2. That's the only interface in VLAN 2. So let's see if that changes the output on the router. So session 3, to jump back to the router now, show IP interface brief. Notice layer 3 interface has come up because there is a layer 2 interface in VLAN 2. So that's good. So ping 192.168.2.254 works. Show IP DHCP binding shows us that an IP address has been allocated to the PC. So on the PC, I'll open up a command prompt or PowerShell in this case and type ipconfig. Notice it's been allocated an IP address in that VLAN. So can it ping its default gateway 2.254? Yes, it can. Can it ping 0.254, which is the IP address of the router in VLAN 1? So again, that IP address there, that works. So inter VLAN routing is working. Can it ping the switch? The switch had this IP address. Now, it's not working because the switch's default gateway is a router in my topology, and that router isn't very intelligent. So the only way we're going to get this to work is to either run a routing protocol or enable NAT so that this network is hidden from the local router. The local router in my infrastructure isn't very clever. It's not running a routing protocol, so it can't work out how to get the traffic back to the PC. So what I'll do here is type interface VLAN 1, IP NAT outside, interface VLAN 2, IP NAT inside. So I'm going to put VLAN 2 on the inside of the NAT configuration. IP NAT inside, source list, let's say 1, interface VLAN 1, and I'll say overload, access list 1, permit any. So show run basically shows us that VLAN 1 is the outside from a NAT point of view. VLAN 2 is the inside, and everything is going to be NATed on that interface. That basically just allows this PC to send traffic to VLAN 1 and get the traffic back again. So notice I can ping the supervisor module now. I can ping my default gateway. And hopefully, if everything works, I'll be able to ping google.com, and that works. And I'll be able to ping cisco.com. So what I've done now is put this PC into VLAN 2. If I had set the default gateway of all my devices to the RSM, rather than just some dodgy little router here in my home network, I wouldn't have had to enable NAT, but I've had to do that so that I don't have to run OSPF or routing protocols within my topology. Okay, so what I'll do is save the configuration of the RSM. I don't have to save the config of CatOS. That's saved automatically. And notice there is my configuration on the switch, very basic configuration. I think that's enough now. Let me know what you think. Did you enjoy this video? Did you enjoy learning about this 5500 series switch? I've got a whole bunch of old Cisco devices that I can demonstrate. I've been doing this for a long time. I remember working on 5500 switches years ago, 6500 switches years ago. But hopefully this is enjoyable in 2025. Please put your comments below, the kind of stuff that you want to see me create content about. I'm David Bombal, and I want to wish you all the very best.